Everyone knows steam locomotives became museum pieces in the 1960s. The diesel revolution swept them aside like yesterday's technology, and by 1970, serious railroads had moved on. But deep in the industrial heartland of China, a fleet of steam engines was doing something impossible, outperforming American-built diesels in head-to-head competition, moving more freight for less money, and doing it well into the 1990s. This wasn't romantic nostalgia or backward thinking. It was cold economic reality, proven in coal tonnage and maintenance logs that would make diesel advocates deeply uncomfortable. The locomotive was the QJ class. The name translates to advance forward. And between 1956 and 1988, Chinese factories built 4,714 of them. At the time, Western rail experts dismissed China's continued steam production as evidence of technological backwardness. Steam was finished. Everyone knew it. The future belonged to diesel-electric power, with its cleaner operation, simpler maintenance, and superior efficiency. American railroads had spent billions replacing their steam fleets, and the results seemed to prove the case. By 1960, steam's share of U.S. freight service had collapsed. The question wasn't whether diesel was better. The question was how anyone could still doubt it. China's railway engineers had a different calculation. They looked at diesel's advantages and asked a brutally practical question. Advantages compared to what? In the abstract, diesel locomotives offered cleaner cabs, less frequent servicing, and higher availability. But China wasn't operating in the abstract. It had massive domestic coal reserves, virtually no oil production, a huge pool of skilled steam mechanics, and an industrial base geared toward heavy manufacturing. Building diesels meant importing oil and importing expertise. Building steam locomotives meant using resources China already had in abundance. So they built the QJ, and they built it right. This wasn't a Victorian holdover limping into the modern age. The QJ incorporated 50 years of steam locomotive evolution, roller bearings on every axle, mechanical stokers that fed coal automatically, advanced valve gear that extracted maximum efficiency from every pound of steam pressure. The boiler operated at 213 pounds per square inch, high enough to compete with anything built in the diesel era. The firebox was massive, designed to burn China's lower-grade coal without losing performance. The whole machine was designed for standardization. Parts were interchangeable across the entire fleet. A maintenance depot in Manchuria could repair a locomotive from Shaanxi without improvising solutions. The QJ weighed 270 tons, rode on 12 driving wheels, and could pull 3,000-ton freight trains across the mountainous terrain of northern China. Its tractive effort, the raw pulling power measured at the rail, reached 63,000 pounds. For comparison, a typical American diesel of the 1970s, like the EMD GP38, produced about 61,000 pounds of tractive effort. The QJ matched diesel performance using technology everyone had written off as obsolete. But raw power wasn't the whole story. The real test was operational cost, and this is where the numbers got uncomfortable for diesel advocates. In China's context, a QJ cost less to build, less to maintain, and less to fuel than an equivalent diesel. Coal was cheap and domestic. Oil was expensive and imported. A steam locomotive required more frequent servicing, but China had tens of thousands of trained steam mechanics and established repair facilities. Switching to diesel meant retraining the workforce, retooling the shops, and creating supply chains for parts that didn't exist domestically. When China did begin importing diesels in the 1970s, mostly from the United States and Europe, railway officials ran direct comparisons. On identical routes, pulling identical loads, QJ locomotives consistently delivered lower per-ton-mile costs than their diesel competitors. The diesels were cleaner and quieter, yes, but they cost more to buy, more to maintain, and far more to fuel. If for a country moving hundreds of millions of tons of coal annually, the math wasn't close. Steam won. Western observers who visited China in the 1980s struggled to process what they were seeing. Here were steam locomotives, supposedly relics of a bygone age, dominating one of the world's largest rail networks. Some chalked it up to communist inefficiency or resistance to progress. But the railway officials who ran the numbers saw something different. They saw a technology perfectly matched to its environment, extracting maximum performance from available resources. The QJ wasn't succeeding despite being steam-powered. It was succeeding because the entire industrial ecosystem around it had been optimized for exactly this kind of machine. The psychological barrier was enormous. In the West, steam had become synonymous with failure. It represented the old way, the inefficient way, the way things were before progress arrived. Diesel wasn't just better technology, it was modernity itself. To suggest that steam might still be competitive in any serious application was to challenge the entire narrative of technological advancement. So the QJ success was ignored, dismissed, or explained away as proof that China hadn't yet caught up with the rest of the world. But the locomotives kept running. Through the 1980s, the QJ fleet continued expanding even as Western nations scrapped the last of their steam heritage. Chinese factories delivered new QJ locomotives in 1985, in 1986, in 1987. The final unit rolled off the assembly line in 1988, 28 years after the last commercially successful steam locomotive had been built in the United States. And unlike America's final steam builds, which were obsolete before they entered service, the QJ remained the backbone of Chinese freight operations for another decade. By the early 1990s, even China began transitioning seriously to diesel and electric power. Not because steam had failed, but because the economic context was finally shifting. Oil prices stabilized, domestic diesel production increased, and the environmental cost of coal smoke in industrial cities became impossible to ignore. The QJ's operational advantages eroded as the conditions that favored it changed. This wasn't vindication for diesel's superiority. It was proof that technology success depends entirely on the context in which it operates. The last QJ locomotives ran in regular service until the early 2000s. Some heritage operations still fire them up for enthusiast excursions, and a handful remain in industrial service at coal mines and steel plants. But their true legacy isn't romantic, it's mathematical. For 30 years, these machines proved that the right technology isn't always the newest technology. It's the technology that solves the problem in front of you with the resources you actually have. The American rail industry never confronted this reality. Diesel had won, history was written, and there was no reason to question it. But in the coal fields and mountain grades of China, another story was being written, one where an obsolete technology outperformed its supposedly superior replacement through simple, ruthless efficiency. The QJ didn't care about progress narratives or modernity. It cared about moving coal, and it did that better than anything else available. History remembers the winners, but it rarely asks whether they won for the right reasons. The diesel revolution succeeded in America because America had oil, because American labor costs made automation essential, because American manufacturing had moved beyond heavy steam-era metallurgy. Those same factors didn't apply in China. The QJ succeeded because Chinese engineers asked the only question that mattered. What works here, with what we have, right now? That question has a way of cutting through assumptions. It strips away the mythology of progress and forces you to confront performance data, maintenance logs, and cost-per-ton-mile calculations. By those measures, the QJ wasn't a relic. It was exactly what it needed to be. A machine built for the world it actually inhabited, and not the world Western engineers thought everyone should want. When the last QJ locomotives finally retired from regular service, they left behind a lesson most of the rail industry never learned. Superior technology is always contextual. What works brilliantly in one environment can fail catastrophically in another, and vice versa. The QJ proved that steam could still compete against diesel, but only when every other factor aligned in its favor. Remove those factors, and diesel's advantages became decisive. Change the context again, and electric traction makes both of them obsolete. The locomotives themselves are quiet now, most of them scrapped or rusting in forgotten sidings. A few still steam occasionally, hauling tourists who want to experience what real steam power felt like. But the numbers they compiled during 3 decades of operational supremacy remain in the archives, undeniable evidence that the technology everyone dismissed as finished still had one more surprise left in the firebox. The QJ didn't just survive into the 1990s. For a brief, remarkable period, it thrived, and in doing so, it rewrote every assumption about what steam locomotives could achieve in the modern age.